Okay, today we're going to work on Accelerations Calculations B worksheet. Acceleration means a change in speed or direction, and it can also be defined as a change in velocity per unit of time. So the worksheet gives you the equation right here. It tells you A stands for velocity, VF stands for final velocity, VI stands for initial velocity, and T stands for time. So the worksheet asks us to calculate the acceleration for the following data. It gives us an initial velocity of 0 meters per second and a final velocity of 24 meters per second, a time of 3 seconds. So now we need to plug what we have in to our equation. So I'm going to take my final velocity and put it where VF would be, so 24 meters per second, and I'm going to subtract 0 meters per second and divide that by the 3 seconds of time I have. When I put that into my equation, I'm going to get 8 meters per second, or otherwise sometimes they say 8 meters per second squared. Okay, number 2. I have 0 meters per second for initial, 35 meters per second for a final, and a 5-second time. So I'll plug that in. Gives me 7 meters per second, or 7 meters squared. Either one is fine. This one, I have an initial of 20 meters per second and a final of 60 meters per second. So I'll do my 60 meters per second minus my 20 meters per second. Divide that by my 10 seconds. Gives me 4 meters per second. Number 4. I have an initial of 50 meters per second, a final of 150 meters per second, and a time of 5 seconds. So I'll do my final minus my initial divided by my time. Gives me 20 meters per second. Number 5. I have an initial of 25 meters per second, a final of 1,200 meters per second, divided by my 1 minute time. So here I have to think about, okay, well, that's a second and that's a minute. I could go ahead and convert, or I could keep it the same and have two different units for my acceleration, which is actually okay in this case. So I'll do 1,200 meters per second minus the 25 meters per second divided by 1 minute. So I'm going to get 1,175 meters per second per minute. Okay, and we can turn the page. A car accelerates from a standstill to 60 meters per second in 10 seconds. Alright, so I'm going to write out my givens. My initial is 0. My final is this number here, that's 60 meters per second. And my time is going to be 10 seconds. So I'm going to plug that into my equation. So I'll do 60 meters per second minus 0 meters per second divided by those 10 seconds. Number 7, A car accelerates from 25 meters per second to 55 meters per second in 30 seconds. What is its acceleration? So I'll write in my givens. It started at 25 meters per second and ended up going 55 meters per second, and that's over 30 seconds. So I'll plug it into my equation. It gives me 1 meter per second per second. Number 8. A train is accelerating at a rate of 20 meters per second per second. If its initial velocity is 20 meters per A, what is its velocity after 20 seconds? We're going to make that an S. Okay, so this one's a little bit different. I'll write in what I have and what I don't have. We have its acceleration here. We have the initial velocity, and we have our time. So we're looking for that final velocity. So I'm going to write out my equation like I've had before. And I'll fill in what I have. So here I'm going to cross multiply. So I'm going to do 30 times 2. This is going to give me 60 meters per second because that one S canceled out, which is going to be equal to VF minus 20 meters per second. Now I'm going to add 20 meters per second to each side. That's going to give me VF, which is going to be equal to 80 meters per second. Number 9. A runner achieves a velocity of 11.1 meters per second 9 seconds after he begins. What is his acceleration and what distance did he cover? We're going to cover this at a later time.